Sketching general rational functions. We're looking at a rational function not in transformational form. So we'll have two methods, sketching graphs in transformational form or non-transformational form. When it's in non-transformational form, we'll find x-intercept, y-intercept, vertical asymptote, and horizontal asymptote. So the x-intercept is what makes y equal 0. When you have a fraction, the only thing that can make y equal 0 is when the top equals 0. So you're asking yourself, what would make that equal 0? And the answer is 5/4. Your y-intercept, let x equal 0. I've got -5/-2, or 5/2. Your vertical asymptote, what are we not allowed to have in the denominator? When x equals 2, that gives us 0 in the denominator, so that's our vertical asymptote. To find the horizontal asymptote, there's 3 rules that we're just going to have to memorize. You always compare the highest degree in the numerator with the highest degree in the denominator. What we mean by this, x, the largest exponent is 1, and in the denominator it's also 1. So we're comparing those two terms. If the exponent on the top is bigger, or on the bottom is bigger, or they're the same size. Example, x squared is bigger than 7x. 2x squared is bigger than 3x. So in this case, the denominator is bigger, and the other one, the numerator, was bigger. 4x squared versus 2x squared. We're comparing the exponents, and this time they're the same size. So we take the highest exponent in top and bottom and compare them. Numerator has a higher exponent. Denominator has a higher exponent. They're both the same. In the situation where the numerator is higher, your horizontal asymptote, we say it does not exist or approaches infinity. So you're expecting your graph to continue getting higher. Horizontal asymptote of 0, expecting your graph to approach 0. On this one, you divide the numerator by the denominator. So 4/2, that would give us an asymptote of 2. So ours, we're this situation. Numerator, denominator, exact same power, divide them, and you get an asymptote of 4. We'll look at that again. You're simply taking the highest exponent on the top and the highest one on the bottom. Figure out which of the 3 situations we're in. In this one, our situation is this one, exponent 1, so you divide them. 4x divided by x gives us 4, and so our horizontal asymptote is 4. When we get to limits, I'll give you an explanation of why this works, but for the moment, you're just going to have to memorize 3 rules. All right, what does our graph look like? Actually, let's back up and see if we can draw it ourselves. X-intercept 5/4, so 1 1/4. Y-intercept 5/2, what's that, 2.5? Vertical asymptote at 2. Horizontal asymptote at 4. So we're pretty sure what's happening here is we pass through the y and the x and we approach our asymptotes. Now, be careful about saying, I'm done, that's it, look at me, I'm finished. What's going on over here though? You're allowed to have x values that are bigger than 2, which means you need y values that are bigger than 2. So your options, you really have 2 choices for what's going on with your graph. Either your graph is down here, or your graph is up here. One of them is obviously wrong. See if you can figure out which one is wrong. The answer, this one is wrong because it needs an x-intercept. We only have one x-intercept, it's at 5/4. You're not allowed to make up x-intercepts, so this is not allowed to happen. That means the rest of your graph has to be up here. Much nicer version is this one. So vertical asymptote 2, horizontal asymptote 4. Find your y and x intercepts. And again, we could not draw the graph down here because we'd need another x-intercept, so it must be up there. Let's try another one. Sketching y equals x squared plus 1. Start by finding x-intercept and y-intercept. To find your x-intercept, the only way to get an answer of 0 is to make the top of a fraction equal 0. So that would be 0. The y-intercept, let all your x's equal 0, and you get 0 as well. Now, there's a quicker way to do this. If we're crossing the x-axis right here, what's your y-intercept? Has to be 0. It's a function. You're not allowed 2 y-intercepts. So if the x-intercept is 0, your y-intercept is going to be 0 as well. Let's go for vertical asymptote and horizontal asymptote. Vertical asymptote is saying what would make the denominator equal 0. Now be careful here. Some people go wrong on this one. You bring the 1 over. We'd be solving x squared equal -1. That only has a solution if we're in the complex numbers. So for that one, I would say there are none. If you got an answer of 1 and -1 because you weren't paying quite enough attention, try plugging in the 1 and you'll see it doesn't work. 1 squared plus 1 is not 0, so there are no vertical asymptotes. Horizontal asymptote, let's go back to those rules we just learned. Compare the highest exponent on the top with the one on the bottom. Which one's bigger? I've got denominator bigger. 2 compared to 1. When the denominator is bigger, the horizontal asymptote is 0. Okay. We're still not quite sure why, but maybe we could think about it. If we went way out here to 1,000,000, you took 1,000,000 divided by 1,000,000 squared. Okay, that's getting closer to 0. So the bigger the numbers are, the closer this comes to 0 because this overwhelms the top. So that kind of makes sense. So horizontal asymptote 0. What would our graph look like? X-intercept 0, y-intercept 0. Vertical asymptote none. Horizontal asymptote 0. Now this might horrify some of you. You're saying there's an asymptote and I've just gone through it. And you might say, am I allowed to do that? So definition of an asymptote. An asymptote is a line that a graph approaches when the x values get very large or very large in the negative direction. Same with the y values. So we're not saying you cannot cross it in the middle. We're saying it's what you approach when you're way out on the extremes. So yes, you can cross an asymptote. Vertical asymptotes are pretty darn rare, but horizontal asymptotes, you pass them if there's a good reason to do so. And a good reason would be an x-intercept. And that's all we've got. Okay, we're going to have to think this one out a bit. If x was 1, what would our y value be? If x was 1, I'm getting 1 over 1 squared plus 1, so 1 over 2. So we're up here. We have to approach the asymptote. So our graph's going to have to come down here. We have to approach our intercept. And do we pass through it or do we bounce? There's only one x-intercept, so it looks like we're going to pass through. What do you think happens on the other side? Same thing, we need to get closer to the asymptote. So there's our graph. Much better version of it is this one. So key things to watch out for. Asymptotes are things that graphs approach as they get very large in the positive or negative direction. Intercepts, remember from polynomials how many times you cross and whether there's a bounce or whether you pass through. This one, x to the power 1, means one x-intercept of 0, so we had to pass through. And then we're taking that beautiful bendable wire and just bending it through these points. So that's why you get the smooth curve. Let's do another one. Sketch x over x squared minus 1. Let's start with the x-intercept. To get an x-intercept, y equals 0. When a fraction equals 0, it's the top that equals 0. X equals 0. Without any thought whatsoever, what is your y-intercept? Must be 0, because if x is 0, y has to be 0, and there's only one y-intercept. Asymptote. What would make the denominator equal 0? We've got x squared minus 1 equals 0. So x squared equals 1. Looks like we've got some asymptotes here. I've got plus or minus 1. Horizontal asymptote. Those were those rules. Compare the exponent in the top to the one in the bottom. Bottom's bigger. So when you're way out here, you've got 1,000,000 divided by 1,000,000 squared. The denominator is dominating. We're going to have an asymptote of 0. What does our graph look like in this situation? Horizontal asymptote of 0. Vertical asymptote of 1. Vertical asymptote of -1. Again, we're a little bit limited and the only point we have is 0. So let's pick a point and see what happens. When x equals 2, what do we get? 2 over 2 squared minus 1. So 2 over 3. So 2 over 3, a little bit smaller than 1. We need to approach the horizontal asymptote. We need to approach the vertical asymptote. Okay, now what's going on in here between 0 and 1? What if x is a half? A half over a half squared minus 1. It's going to give us a negative in the bottom, so we're getting a negative. That means we're down here somewhere. So we're down here approaching the asymptote. Now, do you pass through there or do you bounce? How many x-intercepts are there at 0? X is to the exponent 1, so there's only one x-intercept. It means we're going to go back up here and approach that asymptote. Okay, what's going on out here? If that were a -2, plugging in -2, we get -2. That would be 4. So -2 over 3, so we're down here somewhere. Approaching that asymptote and approaching that asymptote. Now, instead of having to pick all those points, there's a slightly quicker way of doing this question. So there's our graph. Looks much cleaner than ours, but it's the same idea. So here's the quicker method. Let's go back to polynomials for a minute. When you look at a polynomial, what happens every time you reach an x-intercept? There's an x-intercept. There's an x-intercept. There's an x-intercept. We're going to deal with the 2 in a minute. Can you see that your graph was negative and then positive? Positive and then negative. Negative and then positive. So every time you cross an x-intercept, your graph changes from negative to positive or positive to negative. The only time that doesn't happen is when you have 2 of them in the same place, because then you get your bounce. Why does that work? Because the reason we want to explore this is it's going to help us graph these. So let's think about it. If you were to the left of +2, so you're at -3. -3 plus 2 is a negative number, so this is a negative times all those. That's why your graph is negative. When you're on the right of -2 at -1, -1 plus 2 is now positive. Positive times all those. So that's why every time you reach an x-intercept, the graph changes sign from negative to positive or positive to negative. The only time it doesn't is when there's 2 or 4 or 6 or 8 intercepts, because then this is always positive. There's no change in sign. Same thing happens with asymptotes. So when you have your asymptotes, this is really x plus 1 and x minus 1. That means your graph will change sign as it crosses an asymptote. So the asymptote for this one is -1. When we're at -1, the graph on this side is negative. On the other side of the asymptote, it's positive. We have an asymptote of 1. On the left-hand side of the asymptote, it's negative. On the right-hand side, it's positive. Let me show you how that's going to help us sketch the graph. So we're just going to do this one again a little bit quicker. X-intercept 0, y-intercept 0. Vertical asymptote 1 and -1. Horizontal asymptote 0. You do need a starting point because we have no information at the moment. So you would start by picking one number. I'm going to work with 2. When x is 2, we get 2 over 4 minus 1. So that's 2/3. So we know our graph is here. We have one asymptote at 1. And our graph is currently positive on this side of the asymptote. That means immediately after crossing it, it's negative, which means our graph is down here. X-intercept must pass through. Graph is positive on this side of the asymptote. When we cross it, it would have to start negative. So our graph is down here. And that will speed up your time when you graph any sort of general rational function. The one thing to watch out for, what if we had a situation like this, x minus 2 squared? This is really two asymptotes at 2. And when you have two things happening, the sign does not change. So a graph like that would have an asymptote at 2. Turns out the horizontal is 0. Your graph is positive. Positive on this side, crosses asymptote, stays positive. Why did it not change when it crossed the asymptote? Because there was an even number. So just watch out for those. All right. It's the same thing every time you do these. Try and do them as quickly as possible using the information I just gave you with the changing of the sign, and get good at them. All right.